In this section, we're going to talk about equally likely events. So that basically means that the outcomes are all equal probability in our experiment. So for example, when you toss a fair die, there are 6 equally likely outcomes, namely 1 through 6. They're all equally likely to show up. So what is the probability of each one of those? Each one of the possible 6 outcomes, like the probability of getting a 1, would be 1 out of 6. The probability of getting a 2 is also 1 out of 6. The probability of getting a 6 would be 1 out of 6, because they're all equally likely, and there are 6 possible outcomes. So 1/6. In general, if an experiment has n equally likely outcomes, so a variable, I'm not putting a specific number there, then the probability of each simple outcome is what? Well, 1 over the total number of possible outcomes, which is n. 1 over n. Now in number 2, let's say we toss a fair coin. There are 2 possible outcomes. The sample space is h and t for heads and tails. Since they are equally likely, we know that the probability of getting heads is the same as the probability of getting tails. They each have probability 50%, or 1/2. And notice those 2 probabilities add up to the whole, to 1. 1/2 plus 1/2 gives you 1. Number 3. Suppose we select at random from a number at random from this set. Make sure all the numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 possibilities. Find the probability that the number is odd. In other words, find the probability that the number is going to be one of these numbers. I chose all of the odd numbers from this set. You might think, oh, it's just going to be half, but not quite, because there's an odd number of elements in this set. So, 1, 2, 3, 4, 5. Each number in S has probability 1 over 11 of occurring, because there are 11 numbers there. Therefore, we have probability of E being the probability of getting a 3 plus the probability of getting a 5, I'm putting them in quotes, plus the probability of getting a 7, plus the probability of getting a 9, plus the probability of getting 11. So that's 1, 2, 3, 4, 5 of them. So if you add up 1/11th for each one of them has probability of 1 over 11. We get 1, 2, 3, 4, 5 elevenths. 5 over 11. So a little under 50%. 5/10 would be 50%. And that's because, let's see, did I miss one? Oh, yes, I did. This whole problem's messed up. Let's fix it. The odd numbers should contain 1. So I'm going to squeeze that 1 right in the front there. 1, 3, 5, 7, 9, 11, So now I left off the probability of 1 plus that. So there are actually 1, 2, 3, 4, 5, 6. 6 over 11. It is just over 50%. Because there's one more odd number in this set than there are even numbers. Notice it starts with an odd and ends with an odd. So there would be 5 even numbers in the set. Okay, number 4. The number of elements in an event or a set is denoted, well, we could do it in 2 different ways. I'm going to write both of them down, but I think this one is the one the book uses. That just means the number of elements in the set E. And just in case we ever see this, I'm going to put or what looks like the absolute value of E. So just think, those don't mean sets. They mean the number of elements in the set. So that's a number. That's a number. We call the collection of elements in the set, in the event, the successes. Since the number of elements in the sample space is n of s, we compute the probability of E as simply this: the number of elements in E divided by the total number of elements in the sample space. N of E over N of S. And again, we might see that written like this. They mean the same thing. Okay? Number 5, randomly draw a number from the integers 1 through 12. That's the experiment. Let E be the event that the number is a prime number. Find E in set notation and find the probability of E. Well, that's pretty straightforward. We did one just like this in the last section, I think. The prime numbers 1 through 12 would be 2, 3, 5, 7, 8, 9, 11. Okay, so the sample space is the numbers 1 through 12, so there are 12 elements in it. So the probability of E is going to be the number of elements in E over the number of elements in the sample space. The number of elements in E is 1, 2, 3, 4, 5. And the number of elements in our sample space was, well, 1 through 12, since that's the numbers we were drawing from. And there are 12 numbers there. So 5/12. Number 6 is just really a kind of a definition. We don't have to write anything down for it. When choosing an element from a set at random, it means that all the elements in the set have equal probability of being chosen. Like when you roll a fair die. The probability of getting a 3 is the same as the probability of a 1, which is the same as the probability of a 6, and so on. All right, number 7. Eddie has 17 red marbles and 23 green marbles in a box. I sometimes like to draw a picture as soon as I get that, so here's the box, and I'll just put something like 17R and 23G. Which means there are 40 total marbles. If one marble is chosen at random from the box, what's the probability that the marble is red? Well, essentially, I didn't define the letters to be sets, but it's the number of red marbles over the number of marbles in the sample space. This is the number in the sample space, 40. So, out of the 40 marbles, 17 of them are red. And that's the probability of when you choose one marble out of that box that it will be red.